All right, number 4. The length of a rectangle is 20 meters and the width is 15 meters. Find the ratio of the width to the length of the rectangle, then simplify the ratio. The width to length. The width is 15 meters and the length is 20 meters. Okay, so those two simplify out. So 15 over 20 simplifies. You divide the top and bottom by 5. Number 5. The measures of the angles in triangle UVW are in extended ratio 1 to 1 to 2. Find the measures of the angles. So if they're 1 to 1 to 2, so then one will be 1x, 1x, and 2x. And remember that in a triangle, all three angles add up to 180. So x plus 2x is 180. So 4x is 180. 180 divided by 4, that's going to give you 45. Okay. So the measure of angle U is 45 degrees. The measure of angle B is 45 degrees. And the measure of angle W is 2 times 45, so it's 90 degrees. Okay, and then for number 6, find the geometric mean in 8 and 12. So the formula is x equals the square root of AB. So you multiply both numbers and then you find the square root of that number. So the square root of 8 times 12 is square root of 96. Okay. Now, a perfect number that divides 96, that's going to be 16. So square root of 16 times the square root of 6 is 4 square root of 6. And the square root of 6 you cannot simplify, so you just leave it like that. Okay. Use the diagram and the given information to find the unknown lengths. So given Rn over Rp is equal to Qm over QL, find Rp. So Rp, we don't know what it is. I'm gonna call it X. Okay, so I'm gonna use this formula. Rn is 4, Rp is X, Qm is 6, and QL is 10. So once I have my setup, I will go ahead and cross multiply. 4 times 10 is 40. 6 times x is 6x. So if I divide both sides by 6, x is equal to 40 over 6, which is 20 over 3. Okay, so that's your answer. Number 8. CD over DB is equal to CE over EA. Okay, so let's see, CD over, so we call that X. X over DB, which is 5, is equal to CE, which is 10, over EA, which is 4. Okay, again, cross multiply. 4x is equal to 50. Divide by 4. 50 over 4 simplifies to 25 over 2. Okay. Next, similar polygons in exercise 9 and 10, determine whether the polygons are similar. If they are, write a similarity statement. Okay. So this rectangle, you can see one rectangle is kind of rotated. So you have to visualize which one corresponds with which. So this longer leg, this longer side corresponds with this one. and then the shorter side corresponds with the shorter side of the other one. So let's check if the proportions are the same. So is 12 to 9 equal to 8 to 6? Okay, on the left, I'm going to divide everything by 3 to get 4 over 3. On the right, I'm going to divide by 2 to get 4 over 3. Okay, so since the sides are proportional, the polygons are similar. So A, B, A, B, C, D is similar to polygon G, H, E, F. For number 10, again, we're going to see if the corresponding sides are proportional. So let's start with the shortest one, which is going to be 15 and 6. The medium one is the 20, the 8. And then the longest side will be the 25 with the 10. So let's see if the proportions are indeed the same. So is 15 over 6 equal to 20 over 8? And is that equal to 25 over 10? Now let's start simplifying. 15 over 6 divided by 3 on both sides to get 5 over 2. 20 over 8 divide everything by 4 to get 5 over 2. And then for 25, divide everything by 5 to get 5 over 2. So yes, the sides are proportional, so the triangles are similar. Okay, so that means that triangle, we could call the first one XYZ, is similar to PQR. I just want to make sure that the letters correspond. Yeah, PQR. Okay. So first we determine if they're similar, and then we write the similarity statement. Here's the similarity statement. And the scale factor. This is the scale factor. Okay, once you simplify the fraction, that will be your scale factor. Okay, 11. Two similar posters have a scale factor of 4 to 5. The large poster's perimeter is 85 inches. Find the smaller poster's perimeter. Okay, so perimeters also correspond using the scale factor. Okay, so we started with the scale factor of 4 to 5. That should be equal to the small perimeter, the perimeter of the small poster over the perimeter of the large poster. So 4 to 5 should be, we have the large poster's perimeter, so that goes in the bottom. What we don't have is the small one, so we're going to call that x. So we're going to go ahead and cross multiply. 4 times 85 is 340. Then x times 5 is 5x. So 340 divided by 5, that's going to be 68. So the small poster's perimeter is 68 inches. Okay, now we get into some proofs here. Here's an example. Okay, remember you need to give your statement and your reasons. Okay, here we can see that angle F and angle B are congruent because they're both right angles. Angle E measures 29 degrees because I used the triangle sum theorem. I subtracted 21 and 90 from 180 to get 61 and 180 from what I subtracted 90 and 61 from 180 to get 29. Okay, so once I see that this is 29 degrees, oops, I forgot a step. So angle E measures 29 degrees and congruent to angle A. Okay. So now that I stated that two angles are congruent, then triangle DFE is similar to triangle CBA by the angle-angle similarity theorem. Let's try it with this one. Statement, reasons. Okay, first, it's given that angle Q and angle T are congruent. Okay, that's given. Okay. Next, we can see that these two angles are congruent because they're vertical angles. So angle RSQ is congruent to angle UST because they're vertical angles. Okay. So now that I have that two pairs of angles are congruent, now I could say that triangle QSR is similar to TSU, triangle TSU, because of the angle-angle similarity theorem. Okay, number 13. Okay, we see we have two right angles. So angle C is congruent to angle F because they are right angles. They have to be congruent to each other. Okay, so that's one pair of angle. Okay, and then using the triangle sum theorem, I could see that angle B is 30 degrees. The measure of angle B is 30 degrees because of the triangle sum theorem. So if angle B is 30 degrees, that means that angle B is congruent to angle E. Okay, because of the triangle sum theorem, we could also use substitution. And finally, since we have two pairs of angles that are congruent, triangle ABC is similar to triangle DEF because of the angle-angle similarity theorem. These we're going to prove to the triangles are similar by side, 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 and side angle side. Okay, so for the first one, let's see. The first one I'm going to use side angle side. And because I see that they share angle C. Okay. They share angle C, so angle C is congruent to angle C. That's the reflexive property. Okay. Now we want to see that the sides are proportional. So this side is, let me use a different pen. Use a pen instead. So this side is for the small triangle, and then this side is for the big triangle. So CB over CA is 4/8, which is 1/2, which is corresponding. And then 3.5, and this big side, I'm sorry, let's go back to the red one. CA is not 8, CA is 12. Sorry about that. So that simplifies to 1/3. Okay. For the little triangle, CD is 3.5 and CE is 10.5. Okay. So CD over CE is 3.5 over 10.5, which is also 1/3. So we have a pair of congruent angles, and then the sides that make those angles are corresponding. So that means that triangle BCD is similar to triangle ACE because of the side angle side similarity theorem. Okay. For 16, let's go ahead and make this table first. Okay. Let's compare. We have the measurements of all the sides. We're going to use side for this one. Okay, for the small triangle, we're going to compare 14 and RQ is 14 and SQ is 21. So 14 over 21, it simplifies to 2/3. It's corresponding. Okay. RU and ST is 10 over 15. It simplifies to 2/3 as well. And then the last pair, the 9, UQ and TQ is 13.5. So UQ over TQ is 9 over 13.5. And if you divide the top and bottom by 4.5, again, you get 2/3. So that's also corresponding. Okay, so since all three pairs of sides are proportional, okay, triangle RQU is similar to triangle SQT by side, similarity theorem. All right, next, the Pythagorean theorem. Find the unknown side length of x. Okay, so Pythagorean theorem is a squared plus b squared is equal to c squared. So here is going to be 16 squared plus 12 squared is equal to x squared. 16 squared is 256. So 144 is x squared. So 400 is equal to x squared. Square root on both sides. So x is equal to 20. 20 times 20 is 400. Okay. Number 5, 6 squared plus 10 squared is equal to x squared. 36 plus 100 is x squared. So 136 is x squared. Square root on both sides. 136 doesn't have a perfect square root, so I'm looking for a perfect number that divides 136. Okay, let's see, 1, 2. So I know 4 goes into 136 34 times. So the square root of 4 times the square root of 34 is x. So 2 square root of 34. Now for 34, the only thing that divides it is 2. 2 times 17 is 34. But none of those numbers have a square root, so that's the most simplified version. Okay, and then for number 6, okay, remember this is C, the one on the bottom. That's the hypotenuse. So we have 12 squared plus x squared is equal to 360. Equals to the square root of 369 squared. Now square root and squaring something at opposites of each other, so you're just left with 369. And if you subtract 144, you get 225. And then the square root of 225 is 15. So they actually simplify nicely. Converse of the Pythagorean theorem. Classify the triangle formed by the side lengths as acute, right, or obtuse. Okay, so for these, you have to see how c squared compares with a squared plus b squared. Okay, if c squared is bigger, it's obtuse. If it's equal, it's right, and if it's less than, it's acute. Okay, so let's see what is 9 squared compared to 6 squared plus 8 squared. Okay, 36 plus 64. Oh, what happened here? 36 plus 64, that's 100. And since 81 is less than 100, it's going to be acute. Sorry. Acute. Okay. Number 8. How does 5 squared compare with 4 squared plus 2 squared? 16 plus 4 is 20. So 25 is greater than 20, so this one is obtuse. Okay. Okay, last one. All right, we have some square roots here. So I need to know what those are approximately. So 2 times the square root of 2 is approximately 2.8. And then 6 times the square root of 3 is about 10.4. So that's C. So this one is C. Okay. So let's go ahead and now compare them. How is 6 times the square root of 3 squared compared to 10 squared plus 2 times the square root of 2 squared? Okay, so 6 squared times 3. Okay, remember the square root of 3 squared, that cancels out, so you're just left with 3. How does that compare to 100 plus 4 times, actually, let me just write out the step, 2 squared times 2. Okay, so 36 times 3, 4 times 2. 36 times 3 is 108. 100 plus 8 is 108. So since these are equal, this is a right triangle. Okay. Then, special right triangle, find the value of x. Write your answer in simplest radical form. Okay, so for 19, we see that the side lanes are the same. So that means the angles are congruent. So this has to be a 45, 45, 90 triangle. So that means that the hypotenuse is equal to the leg times the square root of 2. So x is equal to 6 square root 2. For number 20, this is a 30, 60, 90 triangle. So, and what we're missing is the short leg, the one that is opposite of the smaller angle. So, one of the formulas for this one is hypotenuse is equal to short leg times 2. So 14 is equal to 2x. So x is equal to 7. 21 is also a 30, 60, 90 triangle. We have the short leg again, and we're looking for the hypotenuse. So we're going to use the same formula. Okay. So x is equal to 8 times the square root of 3 times 2. You could go ahead and multiply the regular numbers to get 16 square root of 3. And that's it.